Counting Part 2. Properties. C0n equals to 1 because C0n equals n factorial over r factorial. Here r equals to 0. So we get n factorial over 0 factorial, n minus 0 factorial, which is equal to 1. Similarly, we can prove C1n equals to n and Cnn equals to 1. Pause the video and compare using calculator these quantities. We notice that C710 equals C310 and C312 equals to C912. In fact, if we have here the same n and the sum of this r and this r equals to n, then these two quantities are equal. So in general, CNR equals CNn minus r. If we want to prove this property, Cnn minus r equals n factorial over n minus r factorial times n minus n plus r factorial, which is equal to Cnr. Pascal's relation. Pause the video and compare the following. All the above are equal because here we have same n and the r are consecutive. So we take the greater r and we add to n plus 1. Okay, similarly here, C710 plus C810 equals C811. We have same n, we add 1, and we take 7 and 8, we take the greater. This relation is called Pascal's relation. In general, CR minus 1 n minus 1 plus CR n minus 1, here we have same n, and here these two numbers are consecutive, so we add here plus 1 and we take the greater r minus 1 and r is the greater. Pascal's triangle, we want to fill this table with the suitable combination C and R. First, the first column is 1, 1, 1, 1 because R equals to 0 and we know the property C0n equals to 1. The second column, here R equals to 1 and n equals to 0, so this cell is impossible. While here 1, 2, 3, 4, 5, 6, because we know that C1n equals to n. The yellow diagonal equals to 1. We fill the yellow diagonal with 1 because Cnn equals to 1. Now, how we fill the remaining cells? Note that all these cells are rejected because here r is greater than n and r must be less than or equals to n. In fact, how we fill the remaining cells? We add here 2 plus 1, the answer is 3, and we write 3 in this cell. 3 plus 3, 3 plus 3 equals to 6, and we write 6 in this cell, and so on. 4 plus 6 is equals to 10, and we write 10 in this cell. 6 plus 4 is equals to 10, and we write 10 in this cell. What is the justification of this process? In fact, for example, if I take this number 5, here this number 5 represents C15. And if I take this number 10, this number 10 represents C52. And according to Pascal, if we add C51 plus C52, the answer is C26. So we can write 5 plus 10 equals to 15, and we write 15 here because this 15 represents the combination C62. So we get this Pascal triangle. Compare these two figures. We have a plus b power 0 is equals to 1. A plus b power 1 equals a plus b. A plus b power 2 equals a square plus 2ab plus b square, and so on. We note that this number 1, we can match it with this number 1, and this number 1 represents C00. Now, a plus b power 1 equals to 1a plus 1b. So the coefficient of these letters are 1, 1, and here 1, 1 represent C10, and the other one represents C11, and so on. A plus b power 2 equals a square plus 2ab plus b squares. Here the coefficient of the letters are 1, 2, 1, where 1 represents C20, this 2 represents C21, and this one represents C22. Also, a plus b power 3 equals 1a cubed plus 3a square b plus 3ab square plus 1b cubed. This one is C30, 3. This is 3 is C31. This is 3 is C32. And this one is C33. So upon expanding a plus b power 3 or a plus b power 4, or in general a plus b power n, the coefficient of these letters are the combinations. For example, 1 is C03, 3 is C13, 3 is C23, 1 is C33, and so on. Similarly, a plus b power 4, if you expand it, it is a power 4 plus 4a cubed plus c a square b square plus 4ab cubed plus 1b4. 1 is C04, 4 is C14, 6 is C24, and 4 is C34, and this one is C44. So we know how the pattern of the coefficient of the letter parts is. What about the letters? Note that here A is all a power 4. Here a loses one power and it gives this power to b. So here we have b power 1 and here we have b power 0 and so on. Here a power 3 becomes a power 2, while the power of b increases, it is b power 2. Then a power 2 loses 1 from its power to become a power 1, while b power 2 becomes b power 3, and finally we have b power 4, that is a power 0 and b power 4. So what do we deduce? In general, Newton's binomial law, a plus b power n equals cn0 an b0 plus cn1 an minus 1 b1 plus cn2 an minus 2 b2, etc., etc., cnn a0 bn. It is not difficult to memorize this rule. First, look to the power of a. We have a power n minus 1, a power n minus 2, a power n minus 3. The power of a decreases by 1 until we get a power 0. Look to the power of b. We have b power 0, b power 1, b power 2, b power 3. The power of b increases by 1 until we get a power n. Look to the combination. We have cn0, cn1, cn2, cn3, etc., etc., until we reach cnn. We can write this rule a plus b power n as summation from p equals to 0 till p equals to n, c and p an minus b power p. That is, if we have, for example, p equals to 0, we get cn0 an b power 0. Then if p equals to 1, we get cn1 an minus 1 b1. If p equals to 2, we get cn2 an minus 2 b power 2, etc., etc. Then if p equals to n, we get cnn a0 b power n. For example, expand a plus b power 5. We have the first term is c5 0 a5 b0, then c5 1 a4 b1, c5 2 a3 b2, c5 3 a2 b3, c5 4 ab4 plus c5 a0 b5. Then we can, using calculator, calculate the value of each combination. c50 equals to 1, a power 5, b power 0 is 1, c5 1 is equals to 5, a power 4, b power 1, c5 2 is equals to 10, a cube, b power 2, etc., etc. Second example, expand 2x minus 3 power 6. Here a is 2x and b equals to minus 3. b equals to minus 3. So we get C06 a power 6 b power 0, where a is 2x and b equals to minus 3, and so on. The power of 2x decreases by 1. The power of minus 3 increases by 1. And using calculator, we calculate these combinations. So we get 64x power 6 minus 576x power 5. For example, here we calculate C61, it is equal to 6, and we multiply it by 2 power 5, which is 32, and we multiply it by minus 3, we get minus 576, and so on. Examples. Without expanding, find the coefficient of x power 3 in the expansion of 3x minus 5 to the power 10. Here we refer to Newton's binomial law, but we use the second form, which is a plus b power n equals summation from p equals to 0 till p equals to n, c n p, a n minus p, b power p. So 3x minus 5 power 10 equals summation from p equals to 0 till p equals to 10, because here we have n equals to 10, c p10, a, which is 3x, power n minus p, that is 10 minus p, times b power p, that is minus 5 power p. Note here we want to find the coefficient of x power 3. So what is the value of p so that we get the variable x power 3? In fact, to get x power 3, we must take p equals to 7. If p equals to 7, we get c 10, 7, 3x power 10 minus 7 minus 5 to the power 7. Using calculator, t 10 c 7 is equal to 120. We multiply it by 3 power 3, and we multiply it by minus 5 power 7, so the coefficient of x power 3 is this number.